we are going to convert a decimal number to an 8-bit unsigned binary number. Now, if you recognize 255 as being 1 less than a power of 2, then you know it's going to be something that is all ones. But if you don't recognize that, that's fine. So 8 bits, so 1, 2, 3, 4, 5, 6, 7, 8. And for a binary number, you have the 1's place, the 2's place, the 4's place, 8, 16, 32, 64, and 128. And then the way you figure out which ones have 1's and which ones have 0's is you take your number and you find whichever one of these is the biggest that doesn't go over 255, and that's 128. So you put a 1 in the 128, and then you subtract 128. You get 15, 4, 2, and I get 127. Then I figure out whichever one is biggest that doesn't go over 127, that's 64. So I put a 1 in 64, and I subtract 64, and I get 33. I get 133. Wait.
60.
I get 63. Thank you. Boy, that, yeah. Whew. Okay, and the next biggest one that doesn't go over that is 32, so I subtract 32, and I get 31, and then 16, and I get 15, and then subtract 8, and I get 7, and then 4, and I get 3, and 3 is 2 and 1, so I can just put that in there. So that's 1, 1, 1, 1. So, but that one was kind of strange, that is all ones. So let's do another one. Let's do 203. So let's do 203. 1, 2, 4, 8, 16, 32, 64, 128. So 128 is the biggest one that doesn't go over. So 203 minus 128. And then, so 203 minus 128, 13, take away 8 is 5. Is that 75? No. Yeah, it's 75. 75, and then 64 is the next biggest that doesn't go over that, so then subtract 64. And then I get 11. And then the next biggest that doesn't go over that is 8, so I subtract 8. And then there's 3 left over, and that's 1 and 2. And then I fill in zeros everywhere else. Okay, so now to convert the unsigned binary number to its decimal equivalent, so I have 1011 1011. My place values are 1, 2, 4, 8, 16, 32, 64, 128. And I'm just going to add together all the places where I have a 1. So 128 plus 32, that's 10. Carry 1 is 6, that's 160. And then 16 That's 176. And then 8 and 2 and 1, that's a total of 11. So I get 187, which may or may not be right. I don't know. Oh, good. Then I'm certain it's right. So 187. And then C and D. So C is 186. And it's said to a how many bit? 8-bit.
Oh, we can cheat and use the less.
Mm-hmm. Did we already have 186?
It's gonna be 103101.
Oh, the less.
Because it's 187.
It's 187 minus 1, right?
Yeah.
Yeah. So 187 minus 1 means I'm just not going to have that last 1 there. So 1, 0, 1, 1, 1, 0, 1, 0.
But that was on there just to make the data.
Yeah.
That would make me mad.
It would make me mad. And then the last one, we have 11010. 11010. I don't know why we have a 5-bit number, but we do. That's the 1's place, the 2's place, the 4's place, the 8's place, and the 16's place. So that's just 16 plus 8 plus 2, which I believe is 26. And then let's go ahead and take a look at.
I much prefer this method of conversion. Take the whole number, divide by 2, what you got left.
Oh yeah, I do too. I can't do that way.
Oh,
I lose track of it.
Yeah.
I love that one.
So
It makes me happy.
Good for you.
you like the subtracting way?
Like
The divide.
The divide by 2 is amazing.
Yeah. Okay. All right.
Once I figured it out, it made me happy. At first, I wasn't getting.
I lose track of where my.
Well, this was not a good question. Why would I convert all? Why would I only have? What is this question? Okay. Yeah, this is okay. Yeah, that one's not bad. Okay, actually, these are not bad. These are not bad. Okay, so convert the following 8-bit positive binary number to 8-bit negative numbers in sign and magnitude, 1's complement and 2's complement. Okay, so what that means is since it is positive, it's the same, positive numbers look the same in all of these representations. So to change the sign of a number, you take its complement. And so to take the complement in sign and magnitude, all you do is change the sign bit. So this is the sign bit. And so to take the complement, you just change the sign bit. So this one is sign and magnitude. To take the complement in 1's complement representation, you flip all the bits. So that's 1's complement. Now, I want to be real clear on something. I'm not changing this number here to sign and magnitude 1's complement and 2's complement. I'm in each of those representations, I'm taking the complement of it. I'm taking this number to start off with. This number is already a sign and magnitude or 1's complement or 2's complement representation. It's the same in all of them. I am taking the complement in each of these different representations. I'm saying I'm starting, so like the first one, I'm starting and assuming this is sign and magnitude and taking its complement. The second one, I'm assuming it's in 1's complement representation and I'm taking its complement. For this third one, I start with the same number, But this time I say I'm in 2's complement representation, and I'm going to take its complement. And so to take its complement in 2's complement representation, you start at the right end of the number, you keep any zeros you find until you come to the first 1, and you keep that 1, and then you flip all the bits that come after it. And part B is really kind of doing the same thing, so I don't want to do that. I want to do something a little bit different. I want to do this instead. I want to do okay, so I want you to tell me what is the decimal value of the 2's complement 8-bit binary number. So I'm telling you already, this is in 2's complement representation. And this is where I discover people really have misunderstandings. They think they know, and then they don't really. So I'm going to pause it for a minute and let y'all work on it, and then we'll see if we get the same answer. I'm gonna change this number, sorry. I'm gonna change this number. I'm gonna make this last bit 0. Sorry. So now the question, so the thing is, it says, what is the decimal value of the 2's complement 8-bit binary number? So before I do this one, I'm going to do another one. And I'm going to say, what is...
Wait, did we get the answer?
No, I didn't give the answer because it's a suspense. What is the decimal value of the same question, 010101110? Okay, what do we have to do with this one? How do we find the decimal value? It's just plain binary. It's a positive number. We know it's positive because the 8th bit is 0. It's just a regular old binary number. We just find its value. Because it's positive, it's the same in all of the representations. This is the 1's place, the 2's place, the 4's place, 8's place, 16, 32, 64. So this number is 64 plus 16 plus 4 plus 2, which is 20, 84, 86 maybe? Possibly? 86? Okay. Can I do that with this one? No, why not? Because it's negative. And because it's negative, I can't just read it and see what it is. I have to take its complement to find the positive value and then figure out what that is. So I'm going to take its complement, which would be 0, 0, 1, because I start at the right, keep all the zeros so I get to the first one, then flip the ones after that. Now I find the value of this positive number, and this is 1, 2, 4, 8, 16, 32, 64, which is 84. And so the answer to the question is negative 84. You got it? You got it? It's not negative 86, it's negative 84.
So I have a question. Instead of doing the quick way like that, could you just flip it and then add 1? again? Or
So the other way to do it is 1 0 1 0 1 1 0 0. So you want to take its complement by the other way of taking a complement, which is by flipping all of the bits and then adding 1.
would you only you wouldn't flip the first one?
No, you do flip the first one.
Really?
Yep. 1 1 0. Carry the 1.
Because
1
you're
is
turning back
0.
right.
Right. That's true.
Carry the 1 0
We just gotta
1
remember.
0 1
Um,
0. And then I get the same number that I still have to figure out what it is. But yeah.
Okay.
Yep.
Okay. Cool.
Can you show us a ones complement?
Yeah. So there's not much to do with 1's complement because I can't remember which professor it was told me. Okay, so 1's complement. Let's talk about 1's complement. First of all, the thing to realize is that that's just saying it's a type of representation. So in positive, they all look the same. So positive, it's the same as all the others. Negative means you flip all the bits. To negative, you take the positive and flip the bits. The problem with 1's complement is it's very difficult to do arithmetic with 1's complement. So if I have a number like this, and I say it's in 1's complement, what is it? What's value is it? Then I see that it's negative. And so to figure out what it is, I have to take its complement. And to take its complement, I'll flip all the bits. And then I figure out what value this is. That's 1, 2, 4, 8, 16, 32. So this is 36. And so my original number in 1's complement representation was negative 36.
So, what's the case where you don't flip that first number? Is that just simply putting it into 1's complement
I think you're
from a negative one?
the other. I think you're thinking of if I have this number and I say it's in 2's complement, then my rule for changing 2's complement my rule for taking the complement of 2's complement is start at the right, keep all zeros, keep the first one you come to, flip everything else. So start at the right, keep all the zeros, there are no zeros, keep the first one that I come to, it's right there. So I kept that one, and then I flip everything else.
Sorry. I always thought that the sign digit remained.
No. That's the main misconception that I'm trying to clear up.
Yeah, everything changes to the left first.
Because you want to make sure that you're able to properly correlate them. The one in the last digit, biggest digit, is just to show you that it's a negative.
No, right. This last bit is not.
It's a sign.
It's basically a sign bit, but it's not just a sign bit. You can't change the sign of the number just by changing it. But it doesn't give you any information about the value of the number. The value of the number, the biggest number you can have with 8 bits is 120. Yeah, 120. No, because you can't use that top one, so it's 127. So you can go from plus or minus 127, and so that's why with 8 bits you think, well, I could have 256 numbers. Well, you can, but half of them are positive and half of them are negative, and you get to count 0 twice because you can have positive and negative 0. But the this first bit, it should naturally end up having the correct. If you follow the rules for taking the complement, it will have the correct value if it's positive or negative. So I started with a negative number. I took the complement, so I should end up with a positive number, and I did. If you do it right, then you can see it that way.
Really quick, is it okay if we go back to this question?
No. Okay. All right. Yeah. Sure.
Let's see the answer.
Shut it down.
Which one?
I think I see it. Yeah, I got it. Okay, I'm good now.
Okay, so that's why I did want to point out that these first questions were just saying take the complement, make these negative. It wasn't asking you anything about what they were. It's just make them negative. And you never, except for sign and magnitude, you never just do anything in particular with that first bit. It should happen on its own. And if it doesn't happen on its own, you're doing something wrong. Okay, so while I'm here, let's see. Let me go ahead and do number 5 at the same time, since we're still working on these things. So why do we even use 2's complement? The reason why is because the adding positive and negative numbers just works. You don't have to know. If I ask you what is negative 7 plus 5, what kind of stuff do you have to do in your head to figure that out?
Big 7 at 5. Yeah. Wait, I'm sorry.
Negative 7 plus 5.
Oh, okay. My bad.
Yeah. So what is negative 7 plus 5? How do you do that in your head? How do you do negative 7 plus 5 in your head? I do 7 minus 5 and I get 2 and then I make it negative, right? Yeah. I mean, I suppose you could say, well, I picture a number line in my head and I go to negative. You don't. You subtract the 2. And so what if I had negative 5 plus 7?
7 minus 5.
But you make it positive. Right. So you have to ask yourself which one is bigger. With 2's complement, you don't have to. It's just going to work. So if I add these two numbers, 0, 0, 1, 0, 1, 1, 0, 0, to 0, 0, 1, 0, 1, 0, 0, 1, you just add them. Now, to see if there's overflow, I pay close attention to the last column. So I took 1. I had a carry in of 1. 1 plus 0 is 1. My carry in is 0. 0 plus 0 plus 0 is 0. And my carry out is also 0. When my carry in equals my carry out, there is no overflow. And my answer is good. That means that there's no problem here. My answer is good. So this number was 32 plus 12 is 44, and this number is 41, which is 85, and this number should be 85. That's 64 plus 16 is 10. It's 80 plus 5, that's 85. So it worked. Okay, so that worked. Now let's try the next one.
55 is the answer.
Yes. It didn't ask for that. I didn't have to do that. I just wanted See if it worked. So 0 plus 0 is 0, 1 plus 1 is 0, carry the 1. 1 plus 1 plus 1 is 1, carry the 1. 1 plus 0 is 1. 1 plus 0 is 1, 0 plus 0 is 0. 1 plus 1 is 1, carry the 1. So my carry in is 1. 1 plus 1 is 1, carry the 1. My carry out is 1. My carry in equals my carry out, so my answer is good. This works.
How'd you get 1 in the second to largest bit?
I shouldn't have had it, should I? It should have been 0, right?
I was.
Yep.
And
I was.
So,
No, do I have another mistake?
so there is overflow in this example.
No, there's still not overflow. Because 1 plus 1 is 0, carry the 1. So my carry in to the last column is 1. 1 plus 1 is 1. Carry the 1. My carry out is 1. If my carry in equals my carry out, there's no overflow. Overflow is not that you have a carry. It's that if your carry in equals your carry out.
So if there wasn't a 1 in the carry in, it would have an overflow.
Right. We'll do an example of that.
Okay.
So this, I'm going to try quickly.
Two large positives.
Yeah.
You made one of those zeros. The second goes like the last, right beside the unsigned, beside the signed bit. Made one of those a 1. That changes.
It would. That's not what I'm trying to do right now. Yeah, but yeah, I'm doing. I'm just checking my answer. Okay, so let me tell y'all what I did, what I just did. So I was just double checking. So, and you can do this on your own if you want to. I found that this value is negative 42, and this value is negative 58. And when I add those together, I get negative 100. And then I checked the value of this, and it is negative 100. So it did work. But notice I didn't have to do any of that to make this happen because 2's complement works. But if I wanted to see what it looks like with overflow, if I took 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 1, and 0, 1, 1, 1, 0, 1, 0, 1. If I add these two numbers together, I get 1 plus 1 is 0, carry the 1. 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 1 plus 1 plus 1 is 1, carry the 1. 1 plus 1 plus 1 is 1, carry the 1. My carry in is 1. So my carry in is 1. And then 1 plus 0 plus 0 is 1. My carry out is 0. My carry in does not equal my carry out. There is overflow. This answer is not good. But I could have looked at it and told you that it was not good. How can I look at it and tell you it's not good?
Because it's a positive.
I added two positive numbers and I got a negative number, so something's wrong, and that's overflow.
So it's just if the carry in and carry out don't match.
That's right.
Okay.
Yep.